friends, let's begin with the first chapter, chemical reactions and equations. To understand chemical reaction, we need to know that these all reactions are occurring due to some change. Now what are these change? See, around us we can see many kind of change. Suppose we mix red color with yellow color, it gives orange color. That is a change. Then we observe change in temperature during morning hours, the noon and night. When ice cube is kept in room temperature, it will melt and turn to liquid form. Okay. Similarly, if we keep water in freezer, we get the solid form of water, that is ice cube. If a glass cup is broken, we find that the physical appearance of that cup is changed because it is broken into pieces. But the chemical component or say chemical property remains same because it is glass. Before breaking it was glass and after breaking also it is glass, but the only thing that changes is its physical appearance. So this is a physical change and not a chemical change. Now during the chemical change, what happens is the molecular structure of that element changes and it will give a different product which may have different physical property as well as chemical property after the process, after the molecular structure is rearranged. Let's understand with this one example. We'll take magnesium strip of 3 to 4 cm long and hold it with a pair of tongs and heat it using a burner. Now what we will find is some dazzling fumes coming out of the strip and white powder material, that is the ash, will be collected, and that powder is nothing but magnesium oxide. Now we had a strip which had a different physical property. Now after burning we have a powder material which is different from the appearance it had before. Now here the magnesium oxide is having different chemical as well as physical property than the magnesium strip we had before. Now the question is how this magnesium oxide came into existence. It is nothing but the magnesium strip burned and reacted with oxygen in air and thus formed magnesium oxide. Magnesium reacted with oxygen and gave the product magnesium oxide can be simply written in the form of chemical equation in chemistry. The way we used to write mathematical equations, similarly we will write equations for chemistry. Now it makes easy for understanding and expressing the reactions. Now let's consider this example and make the chemical equation. That will be Mg plus O2 will give the product MgO, magnesium oxide. Magnesium and oxygen, Mg plus O2, are the reactants on the left hand side and on right hand side is the product. So reactants are written on left hand side and the product is written on the right hand side. Plus indicates the reaction between the two atoms. Arrow indicates the process that is happening. It is important also because it will show the direction. Direction means is it reversible or irreversible. Now reversible is melting of ice to water and freezing of water to ice is a reversible process. And irreversible will be an arrow shot from a bow hits the target and cannot return back and set in the bow. That is irreversible example. Now in this example, Mg plus O2 giving MgO is a basic idea. Okay, we know about the reactants, we also know about the product, but it is very important to match the number of atoms on the left hand side and right hand side because this is equation. When we don't know about the total number of atoms, this equation Mg plus O2 giving MgO is known as skeletal chemical equation. But this skeletal chemical equation won't be sufficient enough to understand and to process the equation for further use. Okay. Now in this universe, everything has to be balanced. The number of atoms on left hand side and the number of atoms on the right hand side has to be equal always. Now let's say there is day, there is night, there is pain, there is happiness, there is good, there is also bad. So everything is balanced. Similarly, this equation also has to be balanced well. Let's understand how to balance the equation with one example. We will take zinc and sulfuric acid. Now zinc and sulfuric acid, Zn and H2SO4 are the reactants. What we get is zinc sulfate, the product will be ZnSO4 plus hydrogen H2. Now just look at the equation. Zn on left hand side and Zn on right hand side are equal. Same number of atoms, there is one Zn, and on product side there is one Zn. H2SO4, H2, two hydrogen atoms. On the product side there are two hydrogen atoms. SO4, so S is 1, on the product side also 1. O4, on the product side also O4. Thus this is a balanced equation. We don't need to do any balancing work here. Now let's take one more example where we have to balance and understand the chemical equations. Now we will take Fe and H2O. So Fe and H2O are the reactants, and on product side we will get Fe3O4 and hydrogen H2. Now look at the number of atoms on the reactant side as well as on the product side. We'll see it is unbalanced. Number of Fe atom are different on reactant and product side. H2 are different. Oxygen atom is also different. Now how to balance this? Balancing is easy. First we will see which is the highest number of atom. It can be on reactant side, it can be on the product side. Now on the product side we see O, oxygen atom is 4. So we'll start with oxygen. On the product side there are 4 oxygen atoms. So on the reactant side what we will do is we will write 4 in front of H2O. So it becomes 4 oxygen, 4O. And on product side there is already O4. By writing 4 in front of H2O, H becomes 4 into 2, 8. 8 hydrogen atom. So what we need to do is on the product side, we'll multiply H2 with 4. Thus it becomes 8 hydrogen atom. So this work is complete. Now on the product side, there are 3 Fe atom. So to balance it, we will write on the reactant side 3 Fe. We will multiply by 3. Thus this equation is balanced. 3 Fe plus 4 H2O gives the product Fe3O4 plus 4 H2. This method of balancing the equation by trial, it is called hit and trial method. We used Fe, we used H2O, and we got some product. But do we know the state of matter, whether it is solid, liquid, gas or aqueous? We don't know the state of matter. Now in processing the equations and taking it for the practical use, we do need to know the state of matter, whether we are taking in the solid form or we are taking in the liquid form. What we do is we have to mention the state of matter in the equation itself so that the information is added on. Now how we indicate the state of matter is by writing S for the solid form, L for liquid, G for gaseous and AQ for aqueous. For this example, we will write FeS in the solid state, H2O in the gaseous state, the product Fe3O4 is in the solid state, plus hydrogen is in the gaseous state. Now when do we use aqueous? AQ. Aqueous we use when the reactants or the product is present as a solution in water. We can still add more information like the temperature used for this reaction. We can add the pressure required we can also add the catalyst required. Now the question is, what is catalyst? Catalyst is something that is required to initiate the process or to activate it, to make it fast, make the reaction fast. That material will be known as catalyst. Thank you friends for watching. Let's meet in the next session with new topics.